Hi, I am Ishika Bhattacharjee, and today we are going to cover types of machine learning. So, now we know what machine learning is. Simply, it is a branch of artificial intelligence that allows computers to learn from data and make predictions or decisions without being explicitly programmed. Now, what explicitly programmed means? So, basically, whenever we are writing any codes, suppose for the spam classifier, we are writing a code that whenever we get a free keyword or a boom type of keyword we are programming, like if this keyword appears, uh, result is spam, and whenever then in the email our machine, the model, finds any that type of keyword, it will predict that it is a spam. Now, what happens when new keywords arise? We have to again go on the program and change it manually every time a new keyword appears, or the hackers get more technical, right? So, explicitly programmed means that we don't need to write the code again and again to improvise it. Our machines will learn it by patterns, by recognizing patterns, and will automatically develop that sense that they can easily identify which one of the emails are spam or not. So this is being explicitly programmed without being explicitly programmed. Now, here is a formal definition you can refer to. Let's move into types of machine learning. So now, machine learning is just like a simple learning we used to do as a kid or even right now. How we learn? We in our childhood, we used to learn from our mistakes. Also, our parents used to scold us for not learning anything or not studying well. By this kind, we can also make our machines learn. Of course, not by scolding it or anything. But yeah, there are basically two types, actually three types, but we are going to cover these two types, that is supervised learning and unsupervised learning. So in our childhood, when we used to learn about algebra, we our teachers gave us some problems or explained some concepts, and we used to solve those problems again by ourselves and then submit it to our teachers. Again, they will evaluate the answers and then evaluate our performance. Simply, we have a supervisor. Now here in machine learning, in supervised learning, it goes the same. The definition would be that a machine learning paradigm in which a model is trained on labeled dataset consisting of input output pairs with the objective of learning a mapping function inputs x to outputs y such that it can accurately predict the output of unseen inputs. Now, what it means that suppose we make our machines, or suppose you have a smaller brother, you have to make him learn about fruits. Now, once you give him a fruit, apple, and tell him that this is an apple, it's a green color apple, it's a red color apple, right? Now, next, when he sees a guava, he might assume it or might identify it as an apple because you have shown him that it is a round shaped structure and green in color, so it's an apple. It's an apple. So now what happens is that we supervise our brother, right? We are giving him some kind of visuals, some features about a proper object, and then he analyzes it and identifies the object. Now, similarly, we are telling our brother that this is an apple. We are labeling the object. Similarly, we label the data set. Suppose a data set of cats and dogs. In that data sets, different images are there labeled as cats and dogs. So we put that data set into our model, and our model learn its features, learn the patterns in the data set, that okay, if these features are there, this is a cat, and these features are there, this is a dog. So by this, our machines are getting trained. So you need to remember that supervised learning works on labeled data sets. And what we do is we map a function from input x to output y. And in unsupervised learning, of course, there would be unlabeled data sets. The data set we have is not labeled. Rather, we have just some raw data and we don't know which class to go and whatever we have to do. So here also we just have input variables, and in those variables our machine will extract the hidden patterns from that, some hidden structures, groupings, and some features by on its own. Now think of an example that you have a pile of clothes around yourself. Now I have told you to organize the pile of clothes, and you don't know which cloth is what. You don't know which is a shirt, which is a pant, which is a t-shirt. You just see some similarity. You see that this pant kind of thing comes in a separate organized way. Like whenever you see a pant structure, maybe it's a true trouser, maybe it's a jeans. Whenever you see a pant structure, you will organize it in a different box. Like it's the similarity. Then you take the shirts, you see that okay, this is kind of a shirt, some linen shirt, some rayon shirt, some cotton shirt, but you don't know that this is called a shirt. So on the basis of similarity, we do groupings. Now, in unsupervised learning, the data set is not labeled. So, on the basis of some features, the data set is being organized. And there are two more types, that is semi supervised learning and reinforcement learning. So, in semi supervised learning, what happens is that in supervised learning, we need labeled data, right? So, for the labeled data, we have to label the data manually, and it is a very tedious process. So that's kind of very hectic, right? So what we do in semi-supervised, we label half of the data, some of the data, and then let our machine label rest of the data or extract some features from the data and then model it. So in semi-supervised learning, simply we label some of the data from that unlabeled data set and then work on it. And reinforcement learning is like we have learned in our childhood. So suppose you were learning to ride a bicycle. So whenever you have pushed a brake or pedaled wrong, you have fallen, right? So you learned that whenever I push this thing, I maybe fall. So that time you learned that you don't have to do that thing. You don't push the brake that way, otherwise you will fall. That's your punishment. And whenever you don't do that, you will ride very smoothly. That's your reward. Or simply we can say that in your exam, when you perform very well, maybe your maybe your parents actually rewards you with something like some sweets or something. So that would be a reward if you do well. And if you perform bad, you maybe get scolded, a good scolding. So that's how reinforcement learning works. In reinforcement learning, there is an agent. Like suppose you have a machine and you put that machine in between of fire and water. So if the machine goes to the fire side, it will get burned. Then it learns that I will get burned. I won't go to this side and come to the water part. There it is okay. So now he understands that which side to go. Now don't take this literally. My machine can't analyze those heat or anything. So simply for a program, suppose for a chess game, my machine is learning that if I do this move, I will be get a checkmate. So in that time, that it's learning. It is learning from its environment. That's reinforcement learning. Now, moving forward, we can see some applications of ML. Now, in supervised learning, the basic applications are in healthcare, finance, business, technology, and education. Like in healthcare, we can identify the diseases prediction. Like for some cancer treatment, I have been given a data set of tumor in the liver, and that's a cancer tumor. So now for different thousands and thousands of images are there in the data set, and I train my model to learn the data to get the feature that this point or this thing is the actual um, cancer spot. And that way, on basis of that data, my machine learns, and whenever some image of that cancer type comes, it will easily predict that yes, the person have cancer or not in the liver. Similarly, for finance, business, technology, education, we have different applications of ML. In unsupervised learning, also we can go to marketing, e-commerce. Like customer segmentation. Every customer is not labeled, right? Like he will buy an apple or he will buy a car. These segmentation you have to do on the basis of their past records. Our machine will get the data that we are already providing it. It will get the data, and from our past records, it will predict that what this customer might buy in my store. So in marketing, unsupervised learning is very better. And similarly for these two also, let's move forward. Okay, that's the types of machine learning I'm going to cover right now. The later of the part we'll cover later. Okay, thank you.